In this video, I'll show you how to find the center, vertices, and foci for an ellipse. This is question 2 in the series. The question reads, find the center, vertices, and foci for the ellipse and major and minor axes. The equation that we are working with is shown below, and this equation is in general form, meaning that it doesn't look like this, where you have fractions underneath the variables. And when an equation is in general form, we cannot derive any useful information related to what we're looking for. What we have to do is convert this general form equation into one that's in standard form. And that requires a lot of work. Namely, you have to complete the square twice. Here's what I mean. Let's start off by grouping the similar terms. The similar terms that we have are these two, this term with this term, and this term can be brought to the other side. Let's go ahead and do that. 9x squared plus 18x plus 25y squared minus 50y is equal to positive 191. Now the reason why we are converting this general form into standard form is because the general form doesn't give us much of a meaning. When you convert it into standard form, you can easily find out the center of the ellipse. You can find out whether it is stretched horizontally or stretched vertically, and you can even find out the semi-major axis and semi-minor axis, which are all the characteristics we are looking for. So once you have it in this position, where you have the terms that are similar together, you want to complete the square. So you want to complete the square for these two terms and the square for these two terms. Let's start with the first two. We have 9x squared plus 18x. Notice that they both have a common denominator of 9. So let's factor out a 9. X squared plus 2x. And I'll also do the same thing for these two terms, even though I want to do it one step at a time. Notice that they both have a 25 in common, so I'll factor that out, leaving us with y to the power of 2 minus 2y is equal to 191. These two binomials are quadratics, so I'll complete the square for both. Starting with this one, we have x to the power of 2 plus x. This is your b term. You take your b term and you divide it by 2. So we have 2 divided by 2. That gives us 1. And then you take this number and you power it. So we have 1 to the power of 2, and that is equal to 1. What we will do with this number 1 is add it and subtract it to this expression. So we have 9 bracket x squared plus 2x plus 1 minus 1. Mathematically, this means the exact same thing as this. The next step is to group the first three terms. So I'll group these together by putting them in brackets. And you'll notice that if you group the first three terms together, you will end up with a perfect trinomial, which means that you can reduce this down into simply x plus 1 to the power of 2 minus 1, and don't forget the outer brackets. This expression is the same thing as that expression. We have successfully completed the square for the first two terms. Let's do the exact same thing for this one. The b term for these two terms is negative 2. We're going to divide negative 2 like we did before by 2, and we end up with negative 1. I'm going to take this number negative 1 and square it, where I end up with positive 1. So I have 25 bracket y squared minus 2y plus 1, this number, minus 1. Once again, I will factor these three terms, and they are a perfect square trinomial. This means that I can reduce this down into y minus 1 squared, and don't forget this minus 1 outside. Let's rewrite this expression with these. We have 9x plus 1 squared, and I'm going to multiply this 9 into this negative 1, so we have negative 9 plus 25 bracket y minus 1 to the power of 2, and I'm also going to multiply this 25 into this negative 1, giving us negative 25 is equal to 191. I will bring these constants over to the other side, where we end up with 225. This equation is starting to look more and more like the standard equation of an ellipse. The only thing that we have to do is make this right side equal to 1. And we can do that by dividing everything by 225. That becomes a 1. Let's find out what 9 divided by 225 is equal to. It's equal to 1 over 25. So x plus 1 squared over 25. And 25 divided by 225 gives us 1 over 9 plus y minus 1 squared over 9 is equal to 1. And from this equation, we can find out, like I mentioned earlier, our A, B, center, and all the other properties that we need. Let's outline what the center of this ellipse is. The center will be at -1 and +1. This represents the x-coordinate of the center. And notice how it's +1, but we chose -1. It's always the opposite symbol. And this is -1, so it's +1. The center is at -1 and 1. Furthermore, the larger of the two denominators, 25, is underneath the x. This means that our ellipse will be stretched horizontally. Let me show you an illustration. I've gone ahead and drawn a Cartesian plane, and we know that the center is at -1 and 1. -1 is over here, and up 1 is over here. So that is the center, which I'll call C. And it's going to be stretched horizontally. So I'll do my best to show you that. Notice that it is wider from here to here than it is from top to bottom. Let's find out what our A and B value are. Our A value is inspired by this 25, where that 25 represents A squared is equal to 25. If you square root both sides, you end up with your A, and that is equal to ±5. That represents the semi-major axis, which tells us the distance from the center to the vertex. That is your A. And it's called semi-major because it's halfway. So to find the major axis, you multiply it by 2. If we multiply 5 by 2, we get the major axis. Major axis is 10. Our B value comes from this part. So we have B squared is equal to 9. Square rooting both sides, we end up with ±3. And that represents the distance from the center to this point P. And B is also referred to as the semi-minor axis. To find the minor axis, you multiply 3 by 2. Therefore, your minor axis is 6. So far, we have derived many of the traits they're asking us. We found the center. We found the major axis, the minor axis. We found our A term and our B term. Using our A and our B, we can actually find out the coordinates of the focus. And the focus will lie somewhere in between here and here. Let's find out the exact coordinates. To do that, we'll use the formula C is equal to the square root of A squared minus B squared. We know what A is. 5 squared minus 3 squared. 25 minus 9. This gives us ±4. So the distance from the focus to the center is 4. How do we find the coordinates? Well, you'll notice that the y-coordinate doesn't change. Therefore, these 2 points will have the same y-coordinate as the center, and that was 1. And the x-coordinate for this one will be -1 minus 4. Remember, plus minus 4. That is -5. And this one will be -1 plus 4, which is +3. These two, this is focus 1 and focus 2, represent the coordinates of the two foci. Now to find the coordinates of the vertices, we'll use the same y-coordinates, and I'll add 5 to -1, giving me 4, the x-coordinate of this point, and I'll add -5 to -1, giving me negative 6. And there you have it. This is our vertex 1, vertex 2, focus 1, focus 2, and there you have it. That is how to find the center, vertices, and foci for an ellipse. Make sure to watch question 1 if you haven't done so already.